So have you ever dreamed of having your own really powerful AI assistant, but then you saw the potential cloud computing bills and got, well, some serious sticker shock? What if I told you that you can build your own private, super cost-effective AI cluster, and you can probably do it with the hardware you already have sitting around? All right, let's dive in and figure out exactly how to make that happen.
Okay, so first, some context. Over the last few months, this personal AI assistant, OpenClaw, has just absolutely blown up. It's become one of the hottest open source projects out there. And its popularity? It's kicked off this kind of gold rush. You've got this whole ecosystem of services just popping up everywhere, from people offering installation help to entire companies selling pre-built OpenClaw machines.
But of course, there's a catch, right? The very thing that makes OpenClaw so brilliant, this whole skills-based architecture, is also what can make it crazy expensive to run on cloud services. We're talking about a hidden cost trap here, and it's catching a lot of people completely by surprise. And that brings us right to the core question we're tackling today. What if you could get all of that incredible AI power, but without those crippling cloud costs? What if you could build your own AI cluster, just using, say, a gaming PC or a local server that you already own? You know, it's actually way more achievable than you probably think. All right, so first things first, let's really break down why these awesome AI assistants can end up costing so much. You got to understand the problem before you can fix it, right? Okay, just look at the difference here. A regular old-school AI agent, it makes one API call for every prompt you give it. Super simple. But OpenClaw, it's a whole different beast. To finish just one task, it might make dozens, sometimes even hundreds, of separate API calls. And yeah, every single one of those calls has a price tag.
And we're not talking about a small difference here. The source material says the token consumption can be tens or even hundreds of times higher. It's just astronomical. And remember, each of those API calls costs you money, and man, they add up fast. It turns this super powerful tool into a really big expense really quickly.
So how do we get around this whole mess? While we build our own private AI brain. Let's check out the architecture for a local setup that's actually going to save us a ton of money.
This diagram pretty much shows the whole concept perfectly. The idea is we use one single powerful computer that has a decent GPU, like a gaming PC or a home server, and that machine acts as the centralized AI brain. This one brain then serves up all the smarts to multiple OpenClaw agents, which are the workers running on all your other computers. You can think of this whole system in 4 basic layers. You've got the LLM host layer, that's your GPU server, the AI brain we just talked about. Then there's the network layer, which is the secure connection that ties everything together. After that is the agent layer. Those are your OpenClaw workers that are actually doing the tasks. And finally, you have the user interaction layer, which is basically just how you control the whole shebang.
Okay, so how do we actually build this thing? We're going to start with the absolute heart of the system, setting up the local large language model, the LLM, that's going to be the engine for our entire cluster.
And you know what? Setting this up is surprisingly easy, all thanks to a fantastic tool called Llama. The process is really just 3 simple steps. You install a Llama on your server, you pick a language model that works with OpenClaw, and then you just run it as a local service. That's it.
And finding the right model couldn't be easier. I mean, they've taken all the guesswork out of it. The Llama library actually tags the models that support the special tool calling functions OpenClaw needs. See? Right there. Under Applications, it just says OpenClaw. Super simple.
And this is the really crucial part. You have options here. You don't need some monster server. Depending on the hardware you've got, you can pick the right model for you. Sure, a big model like Qwen3.5 is awesome if you have an RTX 4090, but you can totally get started with a smaller version on something super common, like an RTX 3060 with 12 gigs of VRAM.
Okay, so our AI brain is up and running. Awesome. Now, for a super important step, we need to create a secure link so our worker agents can talk to the brain, without exposing our whole system to the public internet.
The magic trick here is a technique called SSH port forwarding, and the best way to think of it is like a secure private hotline. It literally creates an encrypted tunnel that goes straight from the agent's computer to the GPU server. This means only people who are supposed to be there can access the model. It's a really simple but incredibly powerful way to keep everything locked down. And setting this up is just a quick 2-step deal. First, you run a single command on the agent's computer. That creates the tunnel. Then you just send a little test API call to make sure the connection is actually live and working. That's pretty much it.
And boom, this right here is what success looks like. When you run that test, you should get a little JSON response back from the model. That's your confirmation. Your secure hotline is officially open, and your agent can now talk to your local AI brain.
All right, the brain is running, the secure connection is locked in, we are in the home stretch now. We're ready for the final step, configuring OpenClaw itself and finally unleashing our brand new private AI cluster.
And this final part is honestly a breeze. You just install OpenClaw on the user's computer. And this is the key part. When it starts asking you for all those cloud API keys, you just skip right past all of that. Instead, you just make one tiny change in a config file that tells OpenClaw to talk to your local Llama service instead.
And here is the moment of truth. After a quick restart of the service, you open up the OpenClaw dashboard and you see that beautiful green Health OK status. That's it. That's the confirmation we've been waiting for. Your agent is officially live and talking to your own private LLM.
But wait, it actually gets even cooler. You can integrate this whole setup with messaging apps, like Telegram. After a super quick pairing process, you can literally chat with and give tasks to your personal AI assistant right from your phone, no matter where you are in the world.
And so here it is, the complete system all tied together. You've got the GPU server acting as the brain, the secure tunnel connecting everything, the OpenClaw agents ready to work, and even remote access through your phone. It's powerful, it's private, and it's an incredibly cheap way to run an AI cluster, all on your own gear.
So, at the end of the day, why does all this matter? Well, for a few huge reasons. 1, you completely control your data. It never leaves your machines. 2, you save a ton of money on API costs. 3, you get the freedom to play around and experiment with any open source model you can find. And maybe most importantly, this whole approach makes running powerful AI something you can actually do on regular consumer-grade hardware.
Which really makes you think about the future, doesn't it? I mean, as these AI agents become a bigger and bigger part of our daily lives, could these private personal AI clusters, could this be the next evolution of personal computing? It's a really fascinating thing to think about.